Consider a function f of x whose second derivative is 5x plus 4 sine x. If f of 0 equals 2 and the first derivative at 0 equals 2, what is the value of the function at 4? To solve this problem, we notice we're going to begin with a second derivative, and we have to get to a first derivative because we're trying to, not a first derivative, but original value of a function, f of x, because we're looking specifically for f of 4. In order to go from a second derivative to an original function, this is going to need the tool of antiderivatives, and that's something we're just beginning to talk about. So that is, let me write down that in order to go from the second derivative down to the original function, we're going to have to take the antiderivative of that second derivative. And doing so, I'm going to write it with the integral symbol, so I'm taking the antiderivative of 5 plus 4 sine x. And when I do this, this is going to bring me down to the first derivative. The antiderivative of the second derivative will bring me down to the first derivative. So in other words, that means that the first derivative is equal to, and let's go ahead and calculate this antiderivative. Now we can apply this new power rule we have for antiderivatives, which says I add 1 to my power, so that's going to give me x squared, and then I divide by that new power in the denominator. So I have 5 halves x squared plus, and now let's take the antiderivative of 4 sine x. Well, I know the derivative of sine is cosine. What about the antiderivative? Well, we're going backwards. So cosine, the derivative of cosine is minus sine. So the antiderivative here has to contain a negative in it, right? Because the derivative of cosine is minus sine. That means the antiderivative of sine actually has to be minus cosine. And then we add c to the end. And we mention this because the derivative of any constant is 0. So when you're taking what we call the indefinite integral or an antiderivative, you always have to include that general constant. So I have my first derivative. And speaking of general constant, the nice thing about this problem is there's what's called an initial condition that can help me out. Right here, I have an initial condition in using the first derivative that can actually assist me in finding the value for my constant. That's what initial conditions often do. Specifically, I'm told that f of prime of 0, or the first derivative evaluated at 0, is equal to 2. So that means if I take my first derivative and I substitute 0 in place of x, that expression has to equal 2 according to the initial condition. And why is this good? Because look at what's happened. I now have an expression equal to 2 where that expression has just one variable, c. So it allows me to solve for the variable c. 5 halves times 0 squared is just 0. 4 times the cosine of 0, okay, use your unit circle or calculator if you need. The cosine of 0 is equal to 1, right? And so I have minus 4 times 1, which is just minus 4, plus c equals 2. Adding 4 to both sides, that tells me that c is 6. So the constant on this first derivative is 6. And I'm going to write down then my new first derivative. So my new first derivative of f is 5 halves x squared minus 4 cosine of x plus, and instead of c, I'm going to put 6 there. That satisfies the initial condition that f prime of 0 equals 2. All right, do you see where to go from here? We're so close. We now have our first derivative, and we need to repeat this process to get our original function. So again, I'm going to take an antiderivative. I'm going to take the antiderivative of the first derivative, and when I do that, that's going to give me my original function. So let's take the antiderivative of 5 halves x to the second minus 4 cosine of x plus 6. We'll need some power rules again. And so that's going to tell me that my new original function is antiderivative of 5/2 x squared. So we're going to add 1 to the power, divide by it. So that's going to give me 5/6, because 3 times 2 on the denominator will be 6. And let's talk about this cosine again. So the antiderivative of cosine, we know it's going to be a sine. The derivative of sine is cosine, so we're going to keep this negative. Remember, the way to find the antiderivatives of these trig functions is we either memorize them or we just do the derivative backwards to check, meaning the derivative of sine is cosine, and so the negative just stays and it works out nice. All right, the antiderivative of 6 is 6x. And when we take an antiderivative, we have to add a constant. This will be a new constant that applies to this one, so it's different than the other constant. But it's a new constant because the derivative of any constant is 0. So we add this to our antiderivatives. But again, I can complete this problem and I can figure out what C is going to be because I have another initial condition that I can substitute and use to solve for C. I'm going to use the initial condition f of 0 equals 2. And just as before, we're going to plug 0 in for x, and that's going to give us 5/6 0 to the third power minus 4 times the sine of 0 plus 6 times 0 plus c. And what does this have to equal this time? Oh, it equals 2 again, so we have to set that equal to 2. Well, 5/6 cubed is just 0. Oh, and this time I have the sine of 0. Using our unit circle or a calculator, we know that the sine of 0 is in fact just 0. And so I have negative 4 times 0, which is just 0, plus 0 plus c equals 2, or finally c equals 2 for this antiderivative. Oh, so let me put some lines here and organize my information a little bit. So on the left, we took the antiderivative of the second derivative and got the first derivative. Then we took the antiderivative of the first derivative and got our original function. But now I can summarize what I have, and I now have that my original function, using this new c value, is just 5/6 x to the third power minus 4 sine of x plus 6x plus 2. Okay, so that's the function value f of x that corresponds to the second derivative being 5x plus 4 sine x with the two initial conditions, f of 0 equals 2 and the first derivative at 0 equals 2. The last step we have is to find out what is f of 4. So that's our last step. We want to figure out what is f of 4. And how do we do that? Well, we substitute 4 in for x. That's going to give us 5/6 times 4 to the third power minus 4 times the sine of 4 plus 6 times 4 plus 2. This is actually a big and messy calculation. Let's pull up the next whiteboard, or pull up the next blackboard, right? And let's see if we can't work this out. All right, so we have that f of 4 is 5/6 times 4 to the third power minus 4 sine of 4 plus 6 times 4 plus 2. 4 cubed is 64, so I've got 5 times 64 over 6 minus 4 times the sine of 4 plus 24 plus 2 is 26. And, oh, we got some fractions going on, right? We're going to cancel. This is going to leave us with 3 and 32 because we can take half of each of those. And that's going to give us, what's that, 160 divided by 3, added to a 26, and then minus 4 sine 4. Let's see that. 26, if we put over a common denominator, so 26 times 3, getting our common denominator, gives us, what's that, 78? So that's 78 over 3. We add this up, and what do we get here? So this gives us that this is 238 over 3 minus 4 sine of 4. I don't think there's any farther mathematically that we could technically go to simplify this expression. MyOpenMath should take this, but if you wanted to calculate this out and get an approximation, make sure that your calculator is in radian mode, okay? And then type in 238 over 3 minus 4 sine 4. I get approximately, when I pull this into my calculator, 82.36. 82.36. And that's it.